What happens at the beginning of the universe when the entire universe was the size of an atom? Whose rules are in charge?
Whoa.
You have a shotgun wedding.
There you go.
Between quantum physics and general relativity.
And, oh my God.
And all of us are pretty sure that quantum physics wins.
Neil deGrasse Tyson is no stranger to discussing the mind-bending frontiers of science. From the mysteries of black holes to the wonders of space travel, he's always found a way to bring the most complex scientific ideas to the masses. But his recent take on a groundbreaking quantum discovery has sparked one of the most profound conversations in modern physics, proof of the multiverse theory. Yes, the idea that there are countless other universes beyond our own may no longer be science fiction, but firmly grounded in science fact. Let's break this down. The multiverse is a concept that's been around for decades, popularized in science fiction but deeply rooted in theoretical physics. It suggests that our universe, everything we know and experience, is just one of countless others. Each of these universes operates under its own rules, potentially with entirely different physical constants, dimensions, and even histories. Some might be eerily similar to ours, while others could be so alien that we couldn't comprehend them. Now, for years, the multiverse theory was just that, a theory, a fascinating idea, but one lacking concrete evidence. It's the kind of topic that would make for a great late-night conversation or a deep dive on Neil deGrasse Tyson's show, Cosmos. But all of that changed with this quantum discovery. At the heart of this breakthrough is quantum mechanics, the branch of physics that deals with the behavior of the tiniest particles in the universe, atoms and subatomic particles. If classical physics governs the big stuff like planets and stars, quantum mechanics governs the small stuff, and it doesn't play by the same rules. One of the strangest phenomena in quantum mechanics is something called quantum superposition. Simply put, a particle can exist in multiple states or positions at the same time, until it's observed or measured. Think of Schrödinger's cat, a thought experiment where a cat in a box is simultaneously alive and dead until someone looks inside. That's quantum superposition in a nutshell. But here's where it gets even weirder. Scientists recently conducted an experiment using advanced quantum computers, machines capable of processing information at mind-boggling speeds. These computers allowed researchers to simulate quantum systems in ways we've never been able to before. What they found was astonishing. When they measured the outcomes of certain quantum processes, the results suggested that our universe wasn't the only outcome. Instead, the data implied that multiple outcomes existed simultaneously, as though branching off into parallel realities. Each measurement didn't just reveal one result, it revealed the possibility of countless others existing in their own right. Neil deGrasse Tyson, always eloquent and passionate when discussing such discoveries, explained it this way. Imagine flipping a coin. In our everyday reality, the coin lands on heads or tails. But in the quantum world, that flip could result in heads in one universe and tails in another. Both outcomes exist, they're just in separate branches of the multiverse. But here's the kicker. This isn't just a philosophical idea anymore. The quantum data is so compelling that it's forcing physicists to seriously reconsider the nature of reality itself. Tyson noted that this discovery is like opening a door we didn't even know existed, one that leads to an infinite number of alternate universes. Now you might be wondering, how does this relate to us? Why does it matter if there are other universes? Well, Tyson argues that this discovery could revolutionize our understanding of everything, from the origins of the universe to the very fabric of existence. Take the Big Bang, for instance. For decades, scientists have believed that the universe began as a singularity, a tiny, infinitely dense point that exploded into the cosmos we know today. But if the multiverse theory is correct, the Big Bang might not have been a one-time event. Instead, it could be just one of countless Big Bangs that have given rise to other universes. Our cosmos might be just one bubble in a vast cosmic ocean. Tyson also pointed out that the multiverse could help solve some of the biggest mysteries in physics, like the fine-tuning problem. This is the idea that the constants of nature, Things like the speed of light or the strength of gravity seem almost perfectly calibrated to allow for the existence of life. If any of these constants were even slightly different, the universe as we know it couldn't exist. In a single universe, this fine-tuning seems almost miraculous, as though it was designed. But in a multiverse, it's just a matter of probability. With countless universes out there, at least one of them was bound to have the right conditions for life. And that's the one we're living in. But this discovery doesn't just have implications for physics. It could also change how we think about our place in the cosmos. Tyson speculated that if the multiverse is real, it might mean there are other versions of us out there, living entirely different lives. Imagine a universe where you made a different choice at a crucial moment. A universe where you took that job, moved to that city, or said yes instead of no. The multiverse suggests that all of these possibilities exist somewhere. Tyson described it as both awe-inspiring and humbling, a reminder that our reality is just one thread in an infinite tapestry. Of course, not everyone is on board with the multiverse theory. Critics argue that it's impossible to test or prove, making it more philosophy than science. But Tyson counters that this quantum discovery changes the game. For the first time, we have empirical data suggesting that the multiverse isn't just a wild idea, it's a real possibility. He compared it to the Copernican revolution, when humanity first realized that Earth wasn't the center of the universe. Back then, the idea seemed outrageous, even heretical. But over time, the evidence became undeniable, and it fundamentally changed our understanding of the cosmos. Tyson believes we're on the brink of a similar paradigm shift with the multiverse. The implications of this discovery are staggering. It could lead to new technologies, new ways of understanding the universe, and even new philosophical questions about the nature of existence. Tyson said it's a reminder of why science matters, not just for the answers it provides, but for the questions it forces us to ask. As Tyson eloquently put it, the multiverse isn't just a scientific concept, it's a window into the infinite possibilities of reality. It challenges us to think beyond our everyday experience and consider the vastness of existence. And while we may never fully understand the multiverse, the journey to uncover its secrets is a testament to humanity's boundless curiosity and determination. So, what does this mean for the future? Tyson speculated that this quantum discovery could spark a new era of exploration and innovation. Scientists will undoubtedly continue to study the implications of the multiverse, using ever more powerful tools and technologies. But it's not just scientists who will be affected. This discovery has the potential to change how we think about everything, from our place in the universe to the nature of consciousness itself. It's a reminder that the cosmos is far more mysterious and complex than we ever imagined. Tyson concluded by saying that this is just the beginning. The multiverse is a frontier unlike any other, one that challenges our understanding of reality and opens up new possibilities for discovery. And while we may never fully grasp its scope, the journey to understand it will undoubtedly transform our world in ways we can't yet imagine. Neil deGrasse. Tyson didn't stop at explaining the fundamental nature of this groundbreaking quantum discovery. He ventured into areas where science fiction meets reality, where the philosophical questions raised by the multiverse start to collide with the practical limitations of science. He posed one of the most intriguing questions of all. If the multiverse exists, how could we ever communicate with it? This question isn't merely hypothetical. It's one that quantum physicists are now grappling with as they analyze the implications of their findings. The challenge is profound. Each universe in the multiverse operates on its own unique set of physical laws and constants. Crossing between them would require technology far beyond anything humanity can currently conceive. And yet, Tyson suggested, the seeds of that technology might already exist in quantum mechanics itself. Quantum entanglement, for example, is a phenomenon where two particles become so deeply connected that the state of one instantly affects the state of the other. no matter how far apart they are. Einstein famously called this spooky action at a distance. Could quantum entanglement be the key to bridging the gap between universes? Tyson speculated that if we could harness the principles of quantum entanglement on a macroscopic scale, it might be possible to establish a kind of cosmic internet linking parallel realities. He admitted that this idea sounds like something out of a science fiction novel, but he reminded us that many of today's technologies, like smartphones and GPS, once seemed equally far-fetched. The implications of such a breakthrough would be staggering. Imagine being able to glimpse into alternate universes, to see how different choices played out, or to learn from civilizations that evolved under entirely different conditions. It would be the ultimate form of exploration, one that transcends the boundaries of space and time. But Tyson also cautioned against getting too caught up in the allure of the multiverse. He emphasized that this discovery raises ethical and philosophical questions that humanity isn't prepared to answer. For instance, if we discovered a universe where humanity never existed, what would that mean for our sense of purpose? If we found a universe where advanced civilizations had conquered disease, poverty, and war, how would we reconcile that with the struggles of our own world? He argued that the multiverse forces us to confront some of the most profound questions about existence. Are we unique, or are we just one of countless variations of humanity scattered across an infinite cosmos? Is our universe special, or is it just one tiny fragment of a much larger reality? Tyson pointed out that these questions aren't just academic. They have real-world implications. If the multiverse is real, it could fundamentally change how we view ourselves and our place in the cosmos. It could challenge long-held beliefs about religion, morality, and the meaning of life. One of the most exciting possibilities, Tyson noted, is that the multiverse could hold the key to solving some of the biggest challenges facing humanity. If we could learn from civilizations in other universes, we might discover new ways to tackle climate change, poverty, and disease. The multiverse could become a kind of cosmic library, offering insights and solutions that we could never have imagined on our own. But Tyson also acknowledged the risks. He warned that the multiverse could become a source of division as people grapple with the implications of this discovery. Some might see it as a threat to their beliefs, while others might use it as an excuse to dismiss the importance of our own universe. He urged us to approach the multiverse with humility and curiosity, recognizing that it's a frontier unlike any other. It's not just a scientific discovery. It's a window into the infinite possibilities of reality, one that challenges us to think beyond our everyday experience and consider the vastness of existence. Tyson also addressed the practical challenges of studying the multiverse. While the recent quantum discovery provides compelling evidence, it's just the beginning. Scientists will need to develop new tools and technologies to explore the multiverse in greater detail. One promising avenue of research is the study of cosmic microwave background radiation, the faint afterglow of the Big Bang. Some physicists believe that subtle anomalies in this radiation could provide clues about the existence of other universes. By analyzing this data with advanced telescopes and supercomputers, scientists might be able to detect the fingerprints of the multiverse. Another approach is the study of black holes, which Tyson described as gateways to the unknown. Some theories suggest that black holes could serve as portals to other universes, offering a glimpse into the multiverse. While this idea is highly speculative, it's one that physicists are eager to explore. Tyson also highlighted the role of quantum computers in advancing our understanding of the multiverse. These powerful machines are capable of simulating quantum systems with unprecedented accuracy, allowing scientists to test hypotheses and explore the implications of their findings. But even with these tools, Tyson acknowledged that the multiverse will remain one of the greatest mysteries of science. He compared it to the search for extraterrestrial life, a question that has fascinated humanity for centuries but remains unanswered. He argued that the journey to understand the multiverse is just as important as the destination. It's a testament to humanity's boundless curiosity and determination. a reminder of why science matters. Tyson concluded by reflecting on the broader implications of this discovery. The multiverse isn't just a scientific concept, it's a reminder of the infinite possibilities of existence. It challenges us to think beyond our everyday experience and consider the vastness of reality. He urged us to embrace the mystery of the multiverse, to approach it with an open mind and a sense of wonder. Because in the end, the journey to understand the multiverse isn't just about discovering new worlds. It's about discovering ourselves. Neil deGrasse Tyson's exploration of this quantum discovery didn't just captivate audiences, it ignited a new wave of global curiosity. As the multiverse theory gained more traction, Tyson urged both scientists and the general public to expand their perspectives and think about the vast unknowns of the cosmos. The new quantum discovery that supposedly proves the multiverse has far-reaching consequences for science, philosophy, and technology, but most of all, for humanity's understanding of its place in the cosmos. Tyson has been consistent in reminding us that, while exciting, we must approach the multiverse theory with both caution and reverence for its complexity. A crucial aspect of this discussion revolves around the philosophical and moral dilemmas the multiverse presents. Tyson acknowledged that the possibility of infinite parallel universes throws our sense of individuality into question. If an infinite number of versions of you exist, making slightly different choices or living entirely different lives, what does that mean for concepts like personal responsibility, free will, or even the meaning of life? He framed this discussion within the context of quantum mechanics. The theory of quantum superposition suggests that particles exist in all possible states simultaneously until they are observed. Extending this to the multiverse, it means that every decision we make could spawn an alternate universe where the opposite choice plays out. Imagine standing at a fork in the road. In one universe, you turn left. In another, you turn right. Each version of you experiences a unique reality, but both versions are equally real. Tyson emphasized that this isn't just a hypothetical scenario. It's a natural extension of what quantum mechanics suggests about the nature of reality. The question then becomes, are these alternate versions of ourselves fundamentally connected to us? Tyson speculated that consciousness itself might play a role in linking parallel universes. Some physicists argue that the observer effect, the idea that observation influences the outcome of quantum events, could extend to the multiverse, meaning our awareness might impact not just our own universe, but others as well. This leads to even deeper questions about the nature of consciousness. Is our mind confined to our physical body, or does it have a quantum component that transcends the boundaries of space and time? If the latter is true, it could mean that our thoughts and decisions resonate across multiple universes, creating a web of interconnected realities. Tyson didn't claim to have definitive answers to these questions, but he encouraged us to think about them as part of a broader exploration of what it means to exist. He argued that the multiverse challenges us to rethink everything we thought we knew about reality, forcing us to confront the limitations of our understanding. He also addressed the potential societal impact of the multiverse theory. If people begin to see themselves as one of countless versions of the same person, it could lead to a sense of detachment or even nihilism. After all, if your actions are just one of infinite possibilities, does anything you do really matter? But Tyson flipped this perspective on its head. He argued that the multiverse doesn't diminish the significance of our actions. It amplifies it. Every choice we make creates a ripple effect across multiple realities, shaping not just our own universe, but countless others. In this sense, our decisions carry even more weight as they contribute to the tapestry of the multiverse. He also pointed out that the multiverse offers a unique opportunity for personal growth. By imagining how different choices might play out in alternate universes, we can gain new insights into our own lives. This thought experiment allows us to explore the consequences of our actions in a way that's both empowering and enlightening. But Tyson also issued a warning. The multiverse is not an excuse to avoid accountability. Just because alternate versions of ourselves might exist doesn't mean we can shirk responsibility for our own actions. Instead, he urged us to use the multiverse as a tool for self-reflection, a way to better understand ourselves and our place in the cosmos. On a broader scale, Tyson discussed how the multiverse could impact our understanding of morality and ethics. In a universe where every possible outcome exists, how do we determine what's right or wrong? Does morality vary from one universe to another? Or is there a universal standard that transcends all realities? These questions are more than just academic. They have real-world implications for everything from law and governance to education and social norms. Tyson argued that the multiverse forces us to think more deeply about what it means to be human and how we should treat one another. He also explored the potential technological advancements that could arise from studying the multiverse. If we can find a way to communicate with or even travel between parallel universes, it could revolutionize fields like medicine, engineering, and artificial intelligence. For example, imagine a universe where a cure for cancer has already been discovered. If we could access that knowledge, it could save millions of lives. Similarly, a universe where advanced renewable energy technologies have been perfected could provide solutions to our current climate crisis. But Tyson cautioned that these possibilities come with significant risks. The multiverse is a double-edged sword, offering both incredible opportunities and profound challenges. He warned that humanity must approach this frontier with a sense of responsibility and ethical consideration. One of the most intriguing aspects of Tyson's discussion was his exploration of the potential for collaboration between universes. He speculated that if advanced civilizations exist in other realities, they might have already found ways to navigate the multiverse. If so, they could serve as mentors, guiding us as we take our first steps into this uncharted territory. But Tyson also acknowledged the possibility that we might not be ready for such a discovery. He argued that humanity must first address its own challenges, like inequality, conflict, and environmental degradation, before it can fully embrace the multiverse. He drew parallels to the exploration of outer space, noting that while the quest to understand the cosmos is important, it must be balanced with efforts to improve life on Earth. Similarly, the study of the multiverse should be seen as part of a broader effort to advance human knowledge and well-being. Tyson also highlighted the role of education in preparing humanity for the multiverse. He argued that schools and universities must teach not just science, but also critical thinking, ethics, and philosophy. These skills are essential for navigating the complex questions raised by the multiverse and ensuring that we use this knowledge responsibly. In the final part of his discussion, Tyson reflected on the cultural and artistic implications of the multiverse. He pointed out that the idea of parallel realities has long been a staple of science fiction, inspiring countless books, movies, and TV shows. But now, he argued, it's time to move beyond fiction and embrace the scientific possibilities of the multiverse. He encouraged artists, writers, and filmmakers to collaborate with scientists, using their creativity to imagine what life in other universes might look like. This collaboration could spark a new wave of innovation, bridging the gap between science and the humanities. It could also help make the concept of the multiverse more accessible to the general public, fostering a sense of wonder and curiosity about the cosmos. Tyson concluded by reminding us that the journey to understand the multiverse is just beginning. This quantum discovery is a milestone, but it's not the final destination. It's a reminder of how much we still have to learn and how far we have to go. He urged us to embrace the mystery of the multiverse, to approach it with an open mind and a sense of wonder. Because in the end, the multiverse isn't just a scientific concept. It's a testament to the infinite possibilities of existence, a reminder that the cosmos is far more vast and complex than we can ever imagine.